Lesson 60 is about factorable trig equations. Both of these quadratic equations, x squared minus 1 equals 0 and x squared plus x equals 0, can be solved by factoring. They can both be solved by factoring. This is the difference of two perfect squares. The square root of x squared is x, and the square root of 1 is 1. So when we have the difference of two perfect squares, we factor at x plus 1, x minus 1. Square root of the first term plus the square root of the second term, square root of the first term minus the square root of the second term. And we get for an answer x equals -1 or x equals +1 when we set both factors equal to 0. In this, we have x squared plus x equals 0. We have a common factor in this problem, and the common factor is x. So when we factor this, we're going to take out the common factor and leave x plus 1 in the parentheses. We take out x and leave x plus 1. Again, we set both factors equal to 0. X equals 0 or x plus 1 equals 0. If x equals 0, x is 0. And if x plus 1 equals 0, x would have to be equal to -1. Okay? Now we can do the same thing when we replace x in equations like these with trig functions. Okay, so instead of having x squared here, we have sine x squared. And it's the difference of two perfect squares still, so it factors as sine x plus 1, sine x minus 1. We set each factor equal to 0, and from this we would get an answer of sine x equals -1. We'd subtract 1 from both sides. We would set this equal to 0. And we would get sine x minus 1 equals 0. Therefore, sine x would have to be equal to 1. We know that 1, -1, and 0 indicate sines or cosines, too, of 1, -1, and 0, indicate that this is a quadrantal angle. If sine x equals +1, the y value, remember, has to be equal to +1, and that would be right there at 90 degrees on the positive x-axis. So we would get an answer for x of x equals 90 degrees, or pi over 2. Usually when we have an x, we are wanting to have our answer in radians. Okay? If it's theta, it means you should answer in degrees. If we have a sign of -1, we would be down here on the negative y-axis. The y value here in the unit circle is -1, and x would be equal to 270 degrees, or 3 pi over 2. Okay, this is exactly like the equation above it. We're going to take a tan x. Tan x is a common factor. Take it outside of the parentheses and put this, what's left, we have 1 tan x there and a 1 here. Again, we set each factor equal to 0. So we have tan x equals 0. When tan x equals 0, it is any place that the sine of x is equal to 0, because an alternative definition for tangent, the original definition is opposite over adjacent, but the alternative definition is sine over cosine. So the sine of x has to be equal to 0. That would be here, where sine is equal to 0, a quadrantal angle, or here, where the y value is 0. So we would have either 0 degrees, or 0 radians, or 180 degrees, or pi radians. Now, if tan x plus 1 equals 0, we're going to have tangent of x equal to -1. I'll come up here. And if the tangent of x equals -1, that means that we are either in the second quadrant here or the fourth quadrant. And in degrees, we would ignore, if you're using your calculator to find this, if you don't know that when tangent is equal to 1, the related angle is equal to 45. You would ignore the negative sign, just put in the 1 and get your related or your reference angle. And in this quadrant, we'd be saying 180 minus 45. It hasn't quite gone 45 degrees. So x would be equal to 135. And in this quadrant, it would be 360 minus 45, and x would be equal to 315 degrees. Okay? You can change that to radians if required. And, okay, up here, what have we got here? We have got tangent squared theta minus 1. Okay, this again, difference of two perfect squares. We're going to solve it by factoring. Whenever you factor the difference of two perfect squares, it's the square root of the first term, square root of the second term. You set each factor equal to 0. And again, we have a tangent of 1 or -1. The related angle we know from the previous problem, or example, is 45. If our tangent is -1, we get 135 and 315 degrees. If the tangent is +1, tangent is positive in the first quadrant and the third quadrant, we would get answers for theta of 45 and 225. Okay, you should always draw your diagrams too. So for the first one, we had tangent equal to -1. We would be here, tan equals theta equals -1, or we would be in the fourth quadrant. Tan theta equals +1. We are either in the first or in the third quadrant. Okay, and so that's how we get our answers. You should always draw your diagrams for these two. Okay, here's a equation, trig equation, just like the one we did at the beginning where we had x squared plus x equals 0. We have a common factor. The common factor is sine theta. We take a sine theta out, and it leaves 2 sine theta minus 1. Okay, if sine theta equals 0, it's a quadrantal angle. Sine is 0 wherever the y value on a unit circle is equal to 0. So that would be at 0 degrees, the coordinates on the unit circle, if that would be x equals 1, y equals 0, or it would be over here at -1, 0, and that would be 180 degrees. So we have theta either equals 0 degrees or it equals 180 degrees. We're going to set this factor equal to 0, so we're going to have 2 sine theta minus 1 equals 0. We would add 1 and then divide through by 2. We would get sine theta equals 1/2. Okay, that's a positive number. Sine is positive in the first quadrant here, and it's also positive in the second quadrant. Both angles are making a 30-degree angle with the x-axis. So we have two angles. Theta equals 30, or theta equals 180 minus 30. which would be 150 degrees. Okay. This, again, this is a little different. We have to subtract 1 to begin, so we make this equation factorable. Remember, when you solve by factoring, everything has to be on one side and 0 on the other side. So this again is cosine squared theta minus 1, difference of two perfect squares. We always factor that as square root of the first plus the square root of the second, square root of the first term minus the square root of the second term. We set each factor equal to 0. Cosine theta equals -1 then, when we set it equal to 0. And this one would be cosine theta minus 1 equals 0. We'd add 1 and get cosine theta equals 1. Cosine is negative. It's a quadrantal angle again. Whenever you see -1, 1, or 0, you're thinking quadrantal. And we would be right here, -1, 0. That would be 180 degrees. And here, the other place where the x value, x, remember, is always the adjacent side, is +1, would be at 0 degrees. So those are the two answers for theta, x equals 0 or x equals 180. And this problem, again, like the last one, we have to subtract this sine x. We have to bring it over to the other side, so we have everything on one side. And again, we have a common factor when we do this. So it is a factorable trig equation. Sine x is in both terms. We take that out. It's the common factor. We have 2 cosine x minus 1 then equals 0. We set each factor equal to 0. If the sine of x is 0, again, it's wherever y is equal to 0. That's right here on the unit circle. And unit, remember, means the radius is 1. And over here at 180. So from this, we get x equals 0 degrees or x equals 180 degrees. And again, when we use x as our variable, we usually want our answer in radians. So it would be 0 and pi. And plus 1, 2 cos x equals 1, divide by 2, and we get cos x is 1/2. Now we know the related angle, and we also know where cosine is positive. Cosine's positive in the first, right here. Related angle is what we get, 60 degrees. Means the adjacent side would be 1, the opposite side √3, and the hypotenuse 2. It's also in the fourth quadrant, making a 60-degree angle with the x-axis. And so we have those two angles, either 60 or 360 minus 60, which would give us a 300-degree angle. And again, when we use x, we usually want our answer in radians. That would be pi over 3 and 5 pi over 3. That concludes lesson 60, factorable trig equations.